Polynomials with Unit 3 today. We're going to go over a bunch of different things with polynomials. There's quite a few notes today. We're going to talk about standard form, putting them in standard form. We're going to talk about naming polynomials. We're going to talk about what degree is a polynomial. We're going to talk about what are the end behaviors. So a lot of things within this piece of it, with this introduction of polynomials that we're going to end up doing today. So first and foremost, just what's a polynomial? So we've got really what we call monomials and polynomials. A monomial isn't anything that, or is an expression of the form a of x to the nth power, or just whatever. Okay, so it's just kind of one term. Mono means one. So in a monomial, you're going to have a number, a variable, and an exponent. At least one of them. I mean, you don't have to have all three. Okay, 5 doesn't have a variable or an exponent, but it's still a monomial. It's one term. There's nothing being added. There's nothing being subtracted. There's nothing being divided by variables, anything like that. It's simply one term. So those are examples of monomials. Monomial is one term. What we're more concentrating on this chapter is we're concentrating on a polynomial. A polynomial is a monomial or the sum or difference of monomials. Okay, so each of the individual pieces in a polynomial is a monomial. So like negative 9x squared, that's a monomial, that's one term. Okay, so technically negative 9x squared, that's a polynomial too, but we just call it a monomial if it's one. Plus 5, because we're adding another monomial to it, 5, it becomes a polynomial. I can change variables. I can have 4ab squared. It's a monomial, but it's also a polynomial. 4x cubed y squared plus 3x squared y squared minus 1. I've got x's, I've got y's, I've got exponents, I've got some numbers, I've got a little bit of everything. As long as they're being added together, it's considered to be a polynomial. Poly means many. Okay, so it's many terms added or subtracted from each other, or many monomials added and subtracted from each other is what's considered to be a polynomial. We're going to do a bunch of different things with these within this unit. We're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. We're going to factor them. We're going to graph them. We've got a lot that we're going to do within this chapter. And this is really the last full chapter of the semester. We've had it broken into two parts. We'll take care of the adding, subtracting, multiplying, and dividing in this first part of the chapter. And the second part of the chapter is then doing a little bit more of the factoring piece of it. So standard form. So I want you to go ahead and write that polynomial down exactly how it is. Negative 2x plus 5 minus 7x squared minus x cubed plus 4x to the fourth. So it's a polynomial. It's the sum or difference of lots of monomials. So the first thing we want to be able to do, and the first thing we have to do, is we have to put it in what's called standard form. Okay? Standard form, the terms are arranged from the largest exponent to the smallest exponent. So it's from the largest exponent to the smallest exponent. And we've talked about standard form a ton when we were talking about quadratics. We said they had to be in standard form in order to factor them. We said we had to go x squared, x, and then the constant. So if we have something like this big, huge thing, and we want to put this thing in standard form, we find our largest exponent, which in this case is 4x to the fourth. We're just going to rearrange it. So we're not changing any signs. We're not moving anything from one side of an equation to another. We're just going to simply rewrite this as 4x to the fourth. Now I've got negative x to the third minus 7x squared minus 2x plus 5. That's now in standard form. I have my largest exponent, 4, down to my constant. So it goes 4, 3, 2, 1, none. Doesn't have to. There can be gaps in there, and that's okay. We just have to go from the largest to the smallest. That's standard form. The degree is the next terminology that you need to know. The degree is the highest exponent of the polynomial. So for your notes, the degree is the highest exponent of the polynomial. If you've written it in standard form, it's going to be the exponent of your first term. So we say that this is a fourth degree, and we'll put a name to it in just a second. But for now, we would say that this is a fourth degree polynomial. And it's fourth degree because my highest exponent is 4. And once you have it in standard form, it's just your first one. Okay? Leading coefficient is the next terminology that we need to talk about. The leading coefficient is the coefficient of the first term in standard form. What does coefficient mean? It's a fancy word for number. So the leading coefficient is going to be the number of the first term when we have it in standard form. So 4 is that number, so our leading coefficient is 4. That makes sense? Last one, self-explanatory, I hope. Number of terms is exactly what it says it is. It's the number of terms. So this polynomial has 1, 2, 3, 4, 5 terms. So when it asks for the number of terms, it's just the number of monomials that are in there. So in this case, there are 5 of them. Okay, so standard form, largest exponent to smallest exponent. Degree, the exponent of the largest of your first term if it's in standard form. Leading coefficient is this first number that you see. And then the number of terms you can all count, I hope. Okay. Now, when we're naming polynomials, they have names. We name them in 2 ways. According to their degree and according to the number of terms that they have. So these need to be in your notes because you need to know these things because you are going to be asked. Okay? So, if the degree is 0, so this first column here is degree. If it's a 0 degree, it's a constant. So this would be something like, an example of this would be something like 5. 5 is a constant. It has a degree of 0. We say it's linear if its degree is 1. So like 5x. The exponent here is understood to be a 1. So if its degree is 1, we say that it's linear. It's quadratic if we have something like 5x squared, where the degree is the second degree. Again, remember we're naming them by the exponent. The exponent is 2, the degree is 2. We call a second degree one quadratic. We've done lots of those. 5x to the third would be considered to be cubic. It's a third degree. If it's fourth degree, we call it quartic. And if it's fifth degree, we call it quintic. Quartic and quintic, those tends to be the ones that mess us up. Constant, linear, quadratic, and cubic, those aren't too bad. Quartic and quintic, I don't know. Just remember them. I don't know. Find a way to remember them. Quartic is 4, quintic is 5. Quarter, there you go. Quarter, there's 4 quarters in a dollar, so quartic is 4. There you go. There's 4 quarters in a dollar, so quartic is 4. Quin, yeah, I got nothing for that one. But it doesn't matter, because now I know quartic's a dollar, so it has 4. It's 4. So that's naming it by its degree. We can also name it by the number of sides that it has, and this is a whole lot easier, and we've done this before. By the number of terms. So this is the number of terms. Monomial is 1 term. So an example of monomial would be like x. That's a monomial, 1 term. Binomial, bi means 2. So a binomial is going to have 2 terms, x plus 2. X is a term, 2 is a term. Tri means 3. Triangles have 3 sides. Trinomials have 3 monomials. So like x, everything we worked with like last chapter, mostly. So x squared plus 2x plus 1. That's a trinomial. Now, this is for the rest of them. Anything over 3, we just say it's a 4th, 5th, 6th, 8th term polynomial. So if it has 27 terms, we just say it's a 27-term polynomial. So anything bigger than 3, you just put that number of terms polynomial. And that's going to be consistent throughout with those. No matter how many it has over 4, we don't care. We just say it's that number of terms polynomial. So for example, I'll give you a couple more seconds to write that down. It was 51 degrees, 52 degrees on Sunday. And I was like -4 today. I think the high for today is like 5. If it's going to be this cold, there could be at least be snow on the ground.
Well, you got your wish. There's a little bit of snow.
It doesn't count. So if I have something like 5x cubed minus 3x plus 5, and we're just asked to name it. So when you're naming it, make sure it's in standard form first. So 5x cubed minus 3x plus 5, it's in standard form already. We're good to go there. We first name it by its degree. It's a 3rd degree polynomial. So 3rd degree is a cubic. So we would say that this is a cubic because it's 3rd degree. It has 3 terms. 1, 2, 3. 3 terms is a trinomial. So we would call this a cubic trinomial. That's the name of it. Has a leading coefficient of 5. Its degree is 3. We've got it in standard form. It's got 3 terms. All of those different types of things we could do. The second one, -3a to the 5th plus a cubed plus 2a to the 2nd minus 3a plus 5. It's in standard form, so we're good there. If I look at the degree, my degree is 5. So 5th degree is quintic. And it has 1, 2, 3, 4, 5 terms. So we call it a quintic 5-term poly, if you were asked to name it. And again, anything more than 4 terms, just to give it the number of terms, call it that number of terms polynomial. Questions with that so far? Okay, so we want to be able to put it in standard form. We want to be able to name it. We want to be able to do all of these different types of things with this. Okay, so let's just look at an example that's not done. So I've got 3 minus 5x squared plus 4x. Here's what I want you to do with this one. I want you to rewrite it in standard form, identify the leading coefficient, identify the degree, identify the number of terms, and then name it. Give you about 48 seconds. All right. So x squared is our biggest. So negative 5x squared plus 4x plus 3. Everybody good with standard form? Leading coefficient, that's the number out in front. So our leading coefficient is negative 5. It's going to come into play here in just a second. Identify the degree. The degree, when it's in standard form, it's a second degree. Number of terms, I count 3. So name the polynomial. Second degree is, go back to our thing, quadratic with 3 terms. Trinomial? Good? Can we do those 5 things? We got one last thing we need to be able to do. Any questions so far? Do we need to do another one, or are we okay? We'll come back and do this one in a minute. So the last thing we have to talk about is we have to talk about what we call end behavior. Our whole goal within this chapter at the end of this, like 4 weeks from now, 3 weeks from now, is we want to be able to graph polynomials. So when we're graphing polynomials, we talk about the end behaviors. Where does the graph start? What quadrant on the coordinate plane does it start coming into the graph? And then where does it go out? Where does it end? But we call them both end behaviors because we really don't know which way the graph is going, so we call them end behaviors. But it's essentially, where does it start and where does it end? What quadrant does it start and what quadrant does it end in? Oh, just work. So which one does it start and which does it end in? So there's 4, and these you have to know. These are on your test. So these 4 things are what's going to happen. So when we're talking about end behavior, you don't need to write any of this down, but the end behavior of a function is a description of what would happen to the graph if you extended it to the left and to the right. And when we're talking about end behaviors, we use 2 things. We use the degree, and we use the leading coefficient. We need those 2 things. With the degree, that's obvious. We just look at the degree. But with the leading coefficient, all we want to know is if it's positive or negative. So I don't need to know what the leading coefficient is. I just need to know if the leading coefficient is positive and negative. There are 4 different types of graphs you could have. So these need to go into your notes. D is going to stand for degree from now on. D is degree. If the degree is even, meaning it's 2, 4, 6, 8, ... And the leading coefficient now forever is LC. And the leading coefficient is positive. This graph end behaviors are going to be in the first and second quadrant. Okay, so in your notes, this right here needs to be in your notes. If it's even and the leading coefficient is positive, that's what the end behaviors of the graph are going to look like. So it might come down here and just go like that. It might be a parabola. It might come down here and do a couple other things and go out of there like that and look like a W. It can do different things depending on how many terms it has and what actual degree it is. But if the degree is even and the leading coefficient is positive, that's what has to happen. The second case, if the degree is even and now the leading coefficient is negative. If that's the case, our end behaviors are going to be in the third and the fourth quadrant. Okay. So this part needs to go into your notes. So again, even 2, 4, 6, 8, 10, 12, 14, whatever. But now our leading coefficient is negative. Then your end behaviors are in the third and the fourth quadrant. If the degree is odd, so 1, 3, 5, ... and the leading coefficient is positive, the end behaviors for that one are in the first and third quadrant. So odd and positive is the first and third quadrant. The only other one you can have is you can have the degree odd and the leading coefficient is negative. If that happens, our end behaviors are in the second and fourth quadrant. Now, how do I keep, even and positive goes up, even and negative goes down. Odd and positive goes up, the slope. Think about slope. Okay, positive slopes go up, right? And that's how you can think about even if it's even and positive. Even and positive is going to end up going up. Okay, it's got to end going up. Okay, but it's ending going up. Same thing with the leading coefficient if it's odd. Okay? It's going in the upward direction from left to right. Okay? If it's odd, it's got a negative slope. So if it has a negative slope, it's going down. Okay, so that's why we've got that. Okay, so now let's go back to the question that we skipped. So we skipped this one, but I'm going to add something to this one. I'm going to add the end behavior onto this one. So we're going to rewrite this polynomial in standard form, identify the leading coefficient, identify the degree, number of terms, name it, and now we're also going to give its end behaviors. So lots to do within this one problem, and this is what you're doing a lot of today. is you're going to have to do these 6 things with your assignment. So give you about 30 more seconds. With any luck, it won't disappear in 30 seconds. That means we have luck. All right, so the rewrite. 8x to the 4th plus 3x squared minus 4. Is everybody okay with that? Identify the leading coefficient. Our leading coefficient is 8. 8's a positive number, so I'm just going to put a positive there too, because that's what I'm going to do with the end behaviors. I don't care what my leading coefficient is. For the end behavior, I just only care if it's positive or negative, and it's going to be positive. Degree, 4th degree. Number of terms, 3. When we name it by its degree and then the number of terms. For the degree, there's 4 quarters in a dollar, so quartic. Trinomial is 3. So it's a quartic trinomial. For the end behavior, if I look at the degree is 4. 4 is an even number, so it's even. The leading coefficient is 8, so the leading coefficient is positive, so I've got even and positive. So even and positive is 1 and 2. And that's all you have to do when you're doing end behavior. This is your answer right here. When you're asked for end behavior, that's what we're asking for. We're asking you to draw that. Okay. Any questions with that one? Okay. Let's look at this one. Negative 5x to the 12th plus 4x to the 5th minus 8x plus 2. Do everything that we've done. It's in standard form probably already. Give me the degree. Give me the leading coefficient. Give me the number of terms. Name it. Do the end behaviors. We're going to do 2 more problems and we'll call it a day. What degree is it? 12th degree. Our leading coefficient. Your leading coefficient is negative 5. Number of terms. As 4 terms. So if we name it, we just say it's a 12th degree polynomial with 4 terms. We don't know what a 12th degree is, so we just say it's a 12th degree polynomial with 4 terms. It's the easiest way to do it. Now, the end behaviors. Our degree, is it even or odd? Even. 12 is an even number. Our leading coefficient is negative. So the end behaviors are in this 3rd and 4th quadrant. Questions with that one? We'll do one more. Right, last one. We're going to do this one right here, nice and short. But same questions. Put it in standard form. What degree is it? What's the leading coefficient? How many terms does it have? Name it and give the end behaviors. Okay, so the degree, first degree, x doesn't have anything there, so there's understood to be a 1 there. So we say it's first degree. Leading coefficient, -4, 2 terms. So first degree is linear, so we've got a linear binomial. It's odd with a negative leading coefficient, so our end behaviors are in the second and fourth quadrants. Okay. Any questions with any of this today? Are we okay?